You are floating on the surface of the Pacific Ocean. The water is calm. The sun is warm on your skin. Then the boat pulls away and you start to sink. Down past the blue, down past the light, down toward a place almost nothing has ever seen. You are heading for the Mariana Trench, and you would not survive the first 10 seconds. For most of your life, the ocean has felt like a backdrop, something you swim in on vacation, something blue on a map. But beneath the surface, only a few hundred meters down, the rules of survival start to break completely. By the time you reach the bottom of the Mariana Trench, nearly 11 kilometers down, you are no longer in your world. You are in something closer to another planet. Let's start with the number that matters most: pressure. At sea level, your body is used to about 1 atmosphere of pressure pressing in on you. You don't feel it because you've never known anything else. But for every 10 meters you descend in seawater, you gain roughly 1 more atmosphere of pressure. By the time you reach the Challenger Deep, the lowest known point of the trench, the pressure climbs past 1,000 atmospheres. That is over 15,000 pounds pressing on every single square inch of your body. To put that in plain terms, it is the equivalent of roughly 50 jumbo jets stacked directly on top of you. Your lungs would be the first to go. Air compresses. Flesh does not in the same way. Without protection, the air spaces in your chest, your sinuses, your inner ears would collapse almost instantly. Researchers studying deep-sea physiology, including teams affiliated with Woods Hole Oceanographic Institution, have spent decades documenting exactly how pressure reshapes biology at extreme depth. Their findings are blunt. A human body without a pressurized vessel would suffer catastrophic barotrauma. That's the medical term for tissue damage caused by pressure change, within a matter of seconds, not minutes. So how do we know any of this if no person has ever simply swum down there unprotected? Because a small number of people have gone close, inside extraordinary machines, and lived to describe it. In 1960, oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh descended into the Challenger Deep aboard a bathyscaphe called the Trieste. Even inside a steel sphere built to withstand the pressure, the dive cracked one of the outer viewing windows. They felt the shudder through the hull. Decades later, filmmaker and explorer James Cameron repeated the descent solo in 2012 in a vessel called the Deep Sea Challenger, built specifically to survive pressure that would crush ordinary submarines like a soda can. Neither mission would have been survivable for a human body alone, for even a fraction of a second. Now picture it. Let's simulate what your final moments would actually look like, stripped of any equipment. You sink past 100 meters, and already your eardrums are screaming with pain if you haven't equalized constantly. You pass 300 meters, the edge of recreational scuba's wildest limits, where sunlight has all but disappeared. You pass 1,000 meters, into the midnight zone, where the only light comes from bioluminescent creatures producing their own glow in absolute darkness. Your lungs, your sinuses, the air pockets in your bones are now being crushed inward by a force your nervous system cannot interpret as anything but catastrophic injury. Most researchers agree that a human without protective equipment would lose consciousness from the trauma before drowning even becomes the more relevant threat. The exact mechanism between barotrauma, nitrogen narcosis, and oxygen toxicity depends on depth and descent speed, but the result is the same. You do not get the chance to feel afraid for long. Here is the counterintuitive twist. You might assume the cold is what kills you first. The Mariana Trench sits at a bone-chilling 1 to 4 degrees Celsius, just above freezing. But cold is not the dominant threat here. Pressure is so overwhelming, so immediate, that hypothermia never gets the chance to start its slow work. Your body would already be in catastrophic physical failure within seconds, long before temperature became biologically relevant. It is a strange kind of reframe. The thing you'd expect to fear, the cold, the darkness, the crushing isolation, isn't actually first in line. Physics gets there before fear does. And yet, astonishingly, life exists down there. Scientists from NOAA Ocean Exploration and teams publishing in journals like Nature have documented amphipods, strange shrimp-like creatures, thriving at the very bottom of the Challenger Deep. Their bodies are built completely differently from yours. Many deep-sea organisms rely on a chemical compound called TMAO, short for trimethylamine N-oxide, which helps stabilize proteins inside their cells against pressure that would mangle ordinary biological structures. Your proteins have no such defense. The molecular machinery that keeps your cells functioning, the proteins that let your enzymes work, your nerves fire, your heartbeat, simply was not built for that environment. Evolution gave the amphipod a chemical shield. It never gave one to you. Think about how strange that really is. The amphipod and you are both made of cells, both made of proteins, water, and electrical signals. The only real difference is a handful of molecular adaptations refined over millions of years in an environment that never stops trying to crush them. Researchers studying these deep trench organisms have found that the deeper a species lives, the higher its concentration of TMAO tends to be, almost like a dial turned up to match the pressure outside. It's one of the cleanest examples in nature of biology adapting to an environment that, on paper, should be completely uninhabitable. Life didn't avoid the trench. It learned the trench's rules and built a body to match them. Now compare that to what happens to a sperm whale, one of the very few large mammals capable of diving anywhere near these depths. Sperm whales have been tracked diving over 2,000 meters in search of food, holding their breath for over an hour at a time. Their rib cages are flexible enough to collapse safely under pressure, and their lungs can deflate without injury, a level of biological engineering your body simply does not have. Even they rarely approach the true depths of the Challenger Deep. If the most pressure-adapted mammal on the planet still can't survive there unprotected, it tells you something about exactly how extreme that environment is, even by nature's own standards. This is the part that should change how you see the ocean floor. You have walked on land your entire life, treating gravity and air pressure as fixed, invisible facts of existence. But you are only built to survive in an extremely narrow slice of the universe's possible conditions. Climb too high, and the air thins until you can't breathe. Dive too deep, and the water itself becomes lethal. Humans have spent generations imagining the threats of outer space, alien planets, hostile atmospheres far from Earth. But one of the most hostile environments in the entire solar system is 11 kilometers straight down, in our own backyard, and almost nobody thinks about it. So what does any of this mean for you standing on dry land, reading this right now? It means the comfort you feel every single day, the simple fact that you can breathe, that your organs hold their shape, that your blood doesn't simply stop circulating under crushing weight, is not something to take lightly. It is a precise, fragile balance, tuned by millions of years of evolution to function in exactly one atmosphere of pressure, exactly the temperature range you call comfortable. Step too far outside it, in either direction, and that balance collapses almost instantly. The Mariana Trench isn't just a deep hole in the ocean. It's a reminder of how narrow the window of human survival actually is, and how much of the planet, even on our own world, remains genuinely alien to the bodies we were given. You will probably never come close to the Challenger Deep. But somewhere beneath the waves you've swum in, somewhere past the light you've taken for granted, that crushing darkness is still down there, waiting, indifferent. And for now, you're still floating safely on the surface, exactly where your body was built to be.